Today we're going to talk about the mole. The mole is a fundamental unit in chemistry, and is a very important unit to understand. It is actually representative of an amount of particles. What I'm going to do to get you started on this is give you an analogy. So what we're going to talk about first is a dozen. A dozen is a nice, simple analogy for a mole because you're already familiar with a dozen. If you have a dozen of something, it means you have 12 of them. So I'm going to take some different items. I've got some paper clips. I've got some pencils. And I've got some pennies. If I have a dozen of each of these items, it means I have 12 of them. However, if I put a dozen of each of these items on the scale, the masses that I'm going to get are going to be different. The paper clips are pretty light, so 12 of them weigh 5.19 grams. Pencils are a little bit heavier and weigh, if I put 12 of them on the scale, they weigh almost 60 grams. And finally, the pennies weigh close to 30 grams. So what we know to be true about a dozen is it is a unit that tells you you must have 12. Oh no. Sorry about that. It's a unit that you must have 12 of something. However, you might have actually different numbers of those. We're going to talk about something called formula masses. So the formula mass could be considered how many grams per dozen you've had. This could be useful if I said, hey, I got 5 dozen paper clips. Could you tell me how much you think they're going to weigh? You could easily just, multiply that number by 5. You could do the same thing with each of these other two numbers. So that's actually going to be an important concept when we talk about gram formula masses for elements. So the big difference between a dozen and a mole is a dozen has 12 and a mole has 6.022 times 10 to the 23rd, which looks something like this. Those really truly aren't all actually zeros. There are digits for a lot of those, but I just wanted, we'll kind of always be using this in scientific notation. This number right here known as Avogadro's number. So I just wanted you to have an idea of what a large, large number this actually is. So this is the number of atoms or molecules that you would have in 1 mole. So just like a dozen means 12 items, a mole means that many particles, and it actually can mean atoms or molecules. This is a really big number because atoms and molecules are such a small quantity, or I'm sorry, so small in size. So we have a large quantity of them. So if we have a mole of any given element, this is how many atoms or molecules of that element we have. In this case, these are all just single atoms. Now, if we actually go to the periodic table and we look at the mass for sodium, for example, it says 22.98977. And I'm actually just going to round that to 22.99. That's actually how many grams per mole we have. So this number of particles right here weighs this many grams. Now, we've talked about this number before in something called the AMU. AMUs actually mean the same thing as grams per mole. So if I told you I had 3 moles of sodium, all you'd have to do is multiply that number by 3. Each mole has a mass of about 23 grams. Mercury is a heavy metal, you might have heard of it before, it has a much higher mass. So 1 mole of mercury, each individual particle weighs more. So a sample, the same number of particles as we have of the sodium, is going to actually weigh a lot more than the sodium did, since the individual particles have a greater mass. Kind of like on our other screen, how the pencils weighed more than the paper clips. Calcium is a little bit closer to sodium. Particles are a little bit lighter than mercury's, but still a little bit heavier than sodium's, so we expect to have a little bit of more mass per mole. Some mole facts for you. 1 mole of rice would cover the land area of the whole world to a depth of 75 meters. 1 mole of rice grains is more grains of rice that have been grown since the beginning of time. In order to eat that many grains of rice, each person on Earth would have to eat 1,797,000, well, I read that wrong, 1,797,000 kilograms of rice. And each kilogram, remember, contains about 50,000 grams. So that's a lot of rice. If you had a mole of marshmallows, you could cover the United States to a depth of 600 miles. Can you swim in a mole of water? Is an interesting mole question. So here's the deal. Think about this for a minute and the facts that we just talked about. But if we actually look up oxygen and hydrogen on the periodic table, the gram formula mass for water is actually our 2 hydrogen atoms times 1.08. This is shown right here, but I'll make it look a little bit clearer. For 1.08 plus we have 1 oxygen with a mass of 15.9994, or 999, we'll round it to. If we add all this up, the gram formula mass for water is actually 18.015 grams per mole. So 1 mole of water is 18 grams of water. And 1 gram of water is about a milliliter of water. So if you actually want to have kind of a thought for how much this is, it's a very, very small amount of water. If you take a look at a typical Nalgene water bottle, that's a liter of water. That's 1,000 milliliters. 18 milliliters is how much space or the volume that you'd actually have of water. So you actually cannot swim in a mole of water. So why do those other numbers seem so, or those other facts seem so overwhelming? Well, water molecules are very, very, very small. So the fact that we have a lot of them still doesn't necessarily give us a huge volume of stuff. Things like marshmallows are big. They're visible to our eyes. So if we have a lot of those, they're going to take up a lot more space. So just a quick thing to wrap up before we get into our next topic. The mole is a representative of 6.02 times 10 to the 23rd particles. Those could be atoms, which remember are just single atoms like this, or they can actually refer to molecules, like in the case of water on the previous slide. The number of atoms in 12, this is actually the number of atoms in 12 grams of carbon-12. That's actually the unit that this is based off of. We already talked about the fact that the AMU is based off carbon-12. This is the Chemist Fundamental SI, or System International, the international unit system used by scientists all around the world. We actually abbreviate this. We like nice 3-letter abbreviations, so we abbreviate this MOL. If you have to write something in moles, please don't just use a lowercase m. That means meters. And an uppercase m actually means a totally different unit called molarity. So you do actually have to use MOL or the full word mole.